Okay, so for separation of variables, the first step is always to cross multiply. So we're going to have y dy equals 2x dx. Okay, so remember that gets us 1 point on the AP exam. Okay, next we're going to antiderive each side. And so we would have y squared over 2 equals x squared plus c. Okay, remember on this, probably since this is not that difficult of an antiderivative, we're going to get 1 point for the antiderivatives, but both would have to be correct, and 1 point for the plus c. Okay, now I would multiply everything by 2, so y squared is 2x squared plus, I'm not really going to write 2c since we don't know what c was, so I'll just write big C. So y is going to be plus or minus the square root of 2x squared plus some unknown constant that we haven't solved for yet. Okay, without any other initial information, I cannot decide what part of the hyperbola we have. So we would have a hyperbola. If you notice this part, we would have y squared minus 2x squared equals c. So depending upon whether c is positive or negative, we would either have a hyperbola opening up and down, or one opening left and right. But remember, regardless, we have to pass the vertical line test. So we may only have the top half, or we could only have maybe the bottom half of a different hyperbola. It would really depend. So without any further information, we can't choose between the plus and minus. For the next question, when we cross multiply, we have dy equals y squared dx. So 1 over y squared dy equals dx. Is our first point. Our second and third point would come from anti-deriving y to the negative 2. It's absolutely not natural log. Natural log is only when we have 1 over y, 1 over x, 1 over u, 1 over anything that can be rewritten as a linear. So y to the negative 2 becomes y to the negative 1 over negative 1 equals x plus c. So we're probably going to get 1 again for the antiderivative and 1 for the plus c. Okay, now the reciprocal, we would have negative 1 over y equals the entire quantity x plus c. So if we try to reciprocal that value, we would have negative y is equal to 1 over the entire quantity x plus c. So y is negative 1 over x plus c would be our final answer. So without an initial value, this problem can only be worth 4 or 5 points. Since this was a relatively simple antiderivative, it's only going to be worth 4 points. Okay, the next question, when we cross multiply, we have dy equals 4y dx. We would get 1 point only when we get separated. And remember, when I separate, since our goal is to solve for the function, so whatever the function happens to be, which in this case is y, we don't take extra stuff with the y. So I'm just going to take the y over and divide. So 1 over y dy is 4 dx, and that would be my first point. If I antiderive, I get natural log absolute value of y is 4x plus c. Since it did have a natural log and wasn't just the power rule, we might get 2 points, 1 for each derivative, and then 1 for the plus c. So we could get 3 points for that line, which really is the only line in the whole thing that's calculus. Everything else is algebra. So the absolute value of y, if I raise both sides to the e, remember has to take the entire side. So the natural log of y cancels to become just absolute value of y. And remember we said that e to the c is going to come down and just be called a. So that is a e to the 4x. So without an initial condition, when I drop the absolute value, y is going to be plus and minus a e to the 4x. So depending upon whether or not the initial condition was positive or negative. So again, this one could be worth 5 points without an initial condition. If you had the initial condition, you could get 6 points. Okay, number 4. If I cross multiply, I have x dy equals y dx. I now need to divide both sides by x and y so that I have 1 over y dy entirely separate from 1 over x dx. So you can't just swap the dy's and the dx's. You're never allowed to divide by dy or dx and have that be on the denominator. Okay, so each of these is going to turn into the natural log. So natural log absolute value of y is the natural log absolute value of x plus c. So if you forget the plus c and you just get y equals x, you're going to have a problem because it won't necessarily be correct. So now we raise both sides to the e. And remember, it's the entire side. So the left-hand side is going to be the absolute value of y. The right-hand side has that e to the c that we talked about earlier, which comes down as a. And now we have e to the natural log absolute value of x, which will cancel. So we can't cancel the c out. We can cancel out after we've pulled it out to be the a. So that means that the absolute value of y is equal to a times the absolute value of x, or y equals plus or minus a times x. We do have to get rid of the absolute value. We do have to have y equals. Okay, now if I cross multiply on the next one, I have dy equals xy dx. So 1 over y dy equals x dx. When I anti-derive, I have natural log absolute value of y is x squared over 2 plus c. When I raise each side, e to a power, I end up with the absolute value of y is ae to the x squared over 2. So y will be plus or minus ae to the x squared over 2. Okay, this next problem uses the same concept of how we, quote, bring down the e to the c. It's the idea that if I multiply, it's the same as adding my exponents. So if I had x squared times x cubed, I would get x to the 5th by adding my exponents. So this multiplication is how we add exponents. So from there, if I cross multiply, du is going to be e to the u times e to the 2t times the dt. I would divide both sides by e to the u. And I would have to rewrite this so that I can use the e to a power rule. So we're going to anti-derive. So technically I could have gotten my first point here, although it wouldn't be the nicest way to anti-derive. Okay, remember what I said about having e alone? That when we take the derivative of e alone, then we simply have to keep the e and multiply by the derivative of the power. If we are anti-deriving e alone, then we can keep the e and divide by the derivative of the power. So that means for this one, we're going to keep the e, and instead of multiplying by -1, we divide by -1. For the next part, we keep the e to the 2t, and then divide by 2, and plus c. So remember, our goal is to solve for the function. So this is like the y variable, dy dx. So we're trying to solve for the function, not for the variable. Okay, so now I have e to the -u is -1/2 e to the 2t, and it really doesn't matter if it's plus or minus c since we haven't solved. Now when I natural log each side, -u is the natural log of -1/2 e to the 2t plus c. We absolutely cannot try to simplify this side because we have a plus and minus. If we have plus and minus with natural log, we cannot simplify. So the best that I could do is multiply both sides by a negative so that my final answer looks like this. Okay, most of the time you get your problems given to you factored out, but it is possible that you would have to factor by grouping. So if I factor 1 out of the first term and a -x out of the second term, we could then pull the groups together and have dx dt is 1 minus x times 1 plus t. So if I cross multiply, dx over 1 minus x is going to be 1 plus t times dt. Okay, now, because I have the negative here, this is a linear on the bottom, so it is definitely a natural log question, but I need to deal with that negative. My goal is to have a 1 in front of the x, a 1 in front of the y, a 1 in front of whatever I'm trying to natural log. So I'm going to factor the negative out and rewrite this as 1 negative and then 1 over x minus 1 instead, dx. is 1 plus t dt. That means negative natural log absolute value of x minus 1 equals t plus 1/2 t squared plus c. Now I do have to move the negative over before I can continue. So I have negative t, negative 1/2 t squared, and the plus or minus c is irrelevant until we solve for c. So remember when I e both sides, and it only happens when I do the e power, I'm going to have absolute value of x minus 1 is a e to the negative t minus 1/2 t squared. So that means that x minus 1 is plus or minus a e to the negative t minus 1/2 t squared. Now if I add 1 to both sides, I have to remember that that 1 is not with the power, so I'm going to go ahead and put the plus 1 in the front. So I have 1 plus or minus a e to the negative t minus 1/2 t squared. Okay, for the next question, when I cross multiply, I have 3y squared dy equals x squared plus 2 dx. So when I anti-derive, I get y cubed equals x cubed over 3 plus 2x plus c. Since we have an odd root, we don't have to worry about the plus or minus. Y is simply the cube root of 1/3 x cubed plus 2x plus c. Okay, cross multiplying the next question, I have 3y squared dy equals x plus sine x dx. So y cubed equals 1/2 x squared. The antiderivative of sine is negative cosine, and then plus c. So again, when I have an odd root, I don't have to worry about plus or minus. So we're going to have the cube root of 1/2 x squared minus cosine x plus c. Okay, for the next question, when I cross multiply, I'm going to have 2 plus x dy equals 3y dx. I'm going to leave the 3 behind with the dx. So I'm going to have dy and 1 over y is equal to 3 over, I'm going to write it as x plus 2 dx. So when I anti-derive, I have a linear on both bottoms. So I have the natural log absolute value of y. I'm going to hold the 3, and since the derivative of x plus 2 is just 1, I can do a regular natural log without having to do a u sub, plus c. So now this time when I e both sides, before I do that, I have a 3 in the way. So I'm going to move that 3 up so that when I e, I'm going to have the absolute value of y is a, because we have e to the c still, e to the natural log of absolute value of x plus 2 cubed. So this will cancel, and y will be plus or minus a, absolute value of x plus 2 cubed. Okay, so for this next one, when I cross multiply, I have 1 plus 4x squared dy equals 1 dx. So then 1 dy is 1 over 1 plus 4x squared dx. This is the format for arctangent. So my u is going to be 2x. My du is going to be 2 dx. So I'm going to use 1/2 du for dx. So as I anti-derive, I have the antiderivative of 1 dy is equal to the antiderivative 1/2 du over 1 plus u squared. So I have y equals 1/2 tan inverse of u plus c, which is 1/2 tan inverse of 2x plus c. Okay, now when I cross multiply, I have y dy equals sine x dx. So anti-deriving, I have y squared over 2. The antiderivative of sine is negative cosine of x plus c. So y squared equals negative 2 cosine of x plus 2 times c, which is just some other unknown constant. So y is equal to plus or minus the square root. And if you like it in a different order, we could put the c first. So it's c minus 2 cosine of x. So it doesn't look like we're trying to take the square root of a negative, but it doesn't really matter. Okay, now this time we're going to get initial conditions that help us to solve. So if I cross multiply, I have x e to the negative t dx equals dt. So I'm going to divide by e to the negative t. But that's the same thing as e to the t dt. So dividing by a negative exponent, I can simply move up. So if I anti-derive now, I have x squared over 2 equals e to the t plus c. So from here, notice the input to output, x is actually the output this time. So we have 1/2 equals e to the 0 plus c. So negative 1/2 is going to be the c, since e to the 0 is 1. So going from there, we have x squared over 2 is e to the t minus 1/2. So x squared is 2e to the t minus 1. And so x would normally be plus or minus the square root. But we're going to go based off of our initial condition. This is x is positive. So since x is greater than 0, we're going to choose the positive square root of 2e to the t minus 1. For our next problem, I'm going to cross multiply, but I'm going to multiply by y and dx on each side. So I have y dy is equal to 1 plus x all over x dx. Now before I anti-derive this, I'm going to try to get rid of that fraction. So I'm going to have 1 over x plus 1 dx. So I can divide both parts are divisible by x. So here. So when I anti-derive, I have y squared over 2 is the natural log absolute value of x plus c. So that means that if I use the initial condition, y squared equals 2 natural log absolute value of x plus 2x plus giant C, that y has to be plus or minus the square root. So if I substitute the negative 4 and I get 16 equals 2 natural log of 1 plus 2 plus c. But the natural log of 1 is 0, so c is going to be 14. That means from here that y squared is 2 natural log absolute value of x plus 2x plus 14. But when I'm doing the square root, y is plus or minus the square root. Since we have a negative value here, we have to choose the negative value to match. So we are going to choose the negative based off the fact that the initial condition was negative. And then we still have 2 natural log absolute value of x plus 2x plus 14 underneath the radical. I did not leave myself enough space, so I'm going to fix that. So I'll write it down at the bottom. So y equals negative square root 2 natural log absolute value of x plus 2x plus 14, which is still under the radical. Okay. Okay, for the next question, I'm going to consider this to be over 1. So we're going to get dy equals y squared plus 1 times dx. So when I divide, I'm going to turn that around because I recognize the pattern is inverse tangent. So we have tan inverse of y equals x plus c. Using my initial condition, tan inverse of 0 equals 1 plus c. 0 equals 1 plus c, so negative 1 is c. So we have tan inverse of y is x minus 1. So to undo tangent and tan inverse, they cancel off each other, tangent and tan inverse. So we have y equals tangent of x minus 1, which you cannot change. You can't leave the 1 outside unless you use some sort of trig identity. So you'd have to do sum or difference of tangent. So we're not going to try to do that. We're going to leave it the way it is. Okay, for the next one, I'm not allowed to have plus or minus. So I'm going to move this over so that we have 2y square root of x squared plus 1 dy over dx equals negative x. So 2y dy is equal to negative x dx divided by the square root of x squared plus 1. Okay, since we have something inside of a square root, we have a u substitution. U is x squared plus 1. du is 2x dx. So 1/2 du is equal to x dx. That means we have 2y dy to antiderive and negative 1/2 du over the square root of u to antiderive. That means the antiderivative is y squared equals negative 1/2, and the antiderivative of u to the negative half is u to the positive half over a half plus c. So y squared is negative square root of x squared plus 1 plus c. So y is equal to plus or minus the square root. So using our initial condition, if y is 1, when x is 0, then 1 equals negative 1 plus c, so 2 has to equal c. So y is plus or minus the square root, but that means we have to choose the positive square root of negative square root x squared plus 1 plus 2. So again, we're choosing this positive based off the fact that the initial y value is positive. For the next question, I'm going to have to subtract over. So I have the square root of y dy dx equals negative square root of x. So I have y to the half dy. It's negative x to the half dx. So anti-deriving, I get 2/3 y to the 3/2 because we add and divide is equal to negative x to the 1/2 becomes x to the 3/2 divided by 3/2 plus c. Using the initial condition, I have 2/3, 4 to the 3/2 equals negative 2/3 times 1 plus c. So that means we have the square root of 4, which is 2, 2 cubed, which is 8, so we have 16 over 3 equals negative 2/3 plus c. So 18 over 3 would have to equal c. So we have 2/3 y to the 3/2 equals negative 2/3 x to the 3/2 plus 18 over 3. Okay, now if I multiply everything by 3 and divide by 2, I have y to the 3/2 is equal to negative x to the 3/2 plus 9. So now, in order to get rid of the 3/2 power, I raise everything to the 2/3, but that means the entire side. So you cannot cancel what's on the right-hand side under any circumstances. That's like trying not to FOIL. This is a foiling situation, so you have to leave that. So we're just going to leave this as negative x to the 3/2 plus 9 all to the 2/3. Okay, for the next problem, cross multiplying, I have y dy equals e to the x dx. So y squared over 2 equals e to the x plus c. So y squared equals 2e to the x plus bigger c. So y is technically plus or minus the square root of 2e to the x plus some constant. Using the initial condition where y is 4, means I have to have the positive square root because we can't have a positive equal to a negative. So we have a positive square root of 2e to the 0 plus c. That means that 4 has to equal the square root of 2 plus c. If I square both sides, then 16 equals 2 plus c, and c equals 14. But now I am choosing y equal to the positive square root, because we have a positive initial condition, of 2e to the x plus 14. Okay, for the next question, we're going to add the natural log over first. So xy dy dx equals the natural log of x. Dividing by x, I have x dy equals 1 over x, natural log of x, and we're going to multiply by the dx. So we divided by the x and multiplied by the dx. Now I have a u sub situation again, and I know this because I know the relationship between natural log of x and 1 over x. So u equals the natural log of x, du is 1 over x dx. So when we substitute in, we're going to antiderive y dy equal to the antiderivative of u du. So y squared over 2 equals u squared over 2 plus c. So if I multiply both sides by 2, I get y squared equals u squared plus random constant times 2 is still just a random constant. I can make it a little different if you like. So then y is technically plus or minus the square root of u squared, which is natural log of x squared, plus a constant underneath the radical. Since we have this initial condition where the y value is 0, I really cannot choose between positive or negative, because y equal to 0 is neither positive nor negative. So that means that 0 equals plus or minus the square root of the natural log of 1 squared plus c. Well, the natural log of 1 is 0, so really c has to be 0. So y equals plus or minus the square root of the natural log of x squared. We cannot choose between positive or negative. And y could be rewritten as plus or minus the absolute value of the natural log of x. Because remember, kind of as a sidebar, the square root of x squared is the same thing as the absolute value. Okay, it does not hurt you, however, to leave without simplifying that out. Okay, for the next one, we have this term is added. So it's dy added to this whole term, which means that entire term has to be subtracted. So dy dx is negative y times x plus 1. So dy over y is negative x plus 1 dx. Notice I didn't take the negative with the y because I want to solve for y equals. I would like y to be alone. So natural log absolute value of y is negative, and I can integrate by leaving the negative on the outside, parentheses, x squared over 2 plus x plus c. But I would have to redistribute the negative at one place or the other. So then absolute value of y is AE. I'm going to go ahead and distribute that negative. Negative 1/2 x squared minus x. Okay. So y is technically plus or minus AE to the negative 1/2 x squared minus x. And I'm going to use my initial condition. So since we're choosing the positive y here, we'll have positive choice here. So 1 equals positive AE. And if I substitute negative 2 in, I get 4 times negative 1/2 plus 2. So 1 equals AE to the 0. So A equals 1. So that means my final answer is y equals positive 1. So we don't really have to write that. If you like, I can write it on there temporarily. E to the negative 1/2 x squared minus x. So there's no plus c because the plus c became the a. Okay, so I need to add this term over. So we have 1 plus x squared dy dx equals 1 plus y squared. Okay, cross multiplying, I'm going to multiply by the dx, but that means that I have dx mixed with the y terms. So we're going to have to divide by each set of terms. We cannot swap the dy and dx. That is not how it works. Okay, so the algebra does not follow. So we have to divide by the terms. So I'm going to have 1 over 1 plus y squared with the dy. It's 1 over 1 plus x squared with the dx. So we have inverse tangent again on both sides this time. So inverse tangent of y is equal to inverse tangent of x plus c. So then inverse tangent with the y value, which is root 3,